All right, so the very last trick I have to teach you is probably one of the more complicated ones. There's some other tricks that I took off because this textbook doesn't use them, but this one does come up, and this is called the conjugate trick, and this one's a weird one. So what it is that you'll be given an expression, and you'll go to simplify it. So we've got cos x over 1 minus sine x, pretty simple. And then we've got our right-hand side, which is secant x plus tan x. So I'm going to change that into 1 over cos x plus sine x over cos x. I notice that I end up with two terms that have a common denominator, so I'm going to write that common denominator and I'm going to add the numerators. So I get 1 plus sine x. Now I want you to look at this. What we ended up with is both sides being as simple as we could make them. Like we can't, there's not much more we could do. But you'll notice that the denominators and the numerators are kind of swapped with opposite signs. So you'll notice this one has a 1 minus sine x on the bottom, and this one has a 1 plus sine x on the top. So again, I took these two expressions, I simplified them both as far as I could go, and I ended up at this place. They're similar, but they're not the same. And there's honestly no other way that I have found to get out of this than to apply the conjugate trick. So the conjugate, or the complement trick, is taking one of the fractions, only one of the fractions, and multiplying it by the conjugate, or the complement binomial to the binomial it has. So for example, this one has 1 minus sine x. So I could take the left-hand side and multiply it by 1 plus sine x over 1 plus sine x. That's its conjugate. Or I would take the right-hand side, which I've already been working with, so I'm probably going to keep doing, and I'm going to multiply by its conjugate, which would be 1 minus sine x. In other words, I'm trying to give this side that 1 minus sine x have somehow. So what I do to the top, I also do to the bottom. All right, now let's see what happens if we apply this trick. I've got 1 plus sine x times 1 minus sine x. If I distribute through, I end up with 1 minus sine x, and then the sine x gets distributed. I get plus sine x minus sine squared x. And then my denominator, I never multiply through until I have to, like till I see that it's not needed to simplify. So I'm going to keep it like that. And I'm going to simplify my numerator. I've got 1 minus sine x plus sine x is gone, so I'm left with 1 minus sine squared x in the numerator, all over cos x times 1 minus sine x. Now going further, I should notice a glaring identity, the 1 minus sine squared x, which could be written as cos squared x all over cos x times 1 minus sine x. And I'm getting those like, feelings, this is going to work, right? And then that will finally, cos x goes into cos squared x to leave a cos x, and I've swapped it. I've got cos x over 1 minus sine x. So again, you're only going to recognize that this conjugate trick is needed because both sides were fully simplified as far as I could tell, but they weren't the same. One of them had a 1 plus sine x, one had a 1 minus sine x. So work with one side only, right? If we were to work with both sides, then I would turn the left-hand side into 1 plus sine x over cos x, and then they would be reverses of each other again. So only work with one side. All right, this is the last one. Give this one a go. So hopefully you paused the video. And so my left-hand side, hopefully you recognize that it's as far as simplified as it can be, and I'm going to work on the right. So I've got secant squared x, which is 1 over cos squared x, minus, now here I've got tan x over cos x. So I'm going to rewrite the tan x as sine x over cos x, all over cos x. So now here's a complex or compound fraction. You could multiply top and bottom by cos x. You'd end up with sine x times cos x divided by cos x is just sine x, and then cos x times cos x is cos squared x. Or I could rewrite this, right? Sine x over cos x divided by cos x. So then I'm going to flip and multiply. And I end up with sine x over cos squared x. So in other words, this term is 1 over cos squared x, and this term is sine x over cos squared x. All right, I have a common denominator of cos squared x, and my numerator is 1 minus sine x. Now, this one's a bit of a funny one. This one doesn't have to be done using the conjugate trick. If you recognized that cos squared x is 1 minus sine squared x, you could factor it as a difference of squares, right? And then you're going to end up with the right-hand side, or sorry, the left-hand side. Or some people might see the conjugate, right? They might go, oh, hey, this one has that 1 plus sine x on the bottom. This one has that 1 minus sine x on the top. This is a conjugate trick one. So again, every identity has more than one way of simplifying it. You know, you might do it and then you look at your neighbors, you're like, yours is totally different, and you guys can both get the same marks. Just don't break any math rules. So for this one, to be honest with you, I feel like it would be easier to make this into 1 minus sine squared x and then factor it as a difference of squares. But I'm going to be consistent, and I'm going to do this using the conjugate trick. So the conjugate, or the complement of 1 minus sine x, is 1 plus sine x. And what I do to the top, I'm also going to do to the bottom. So then on the top, I've got 1 minus sine x times 1 plus sine x. Hopefully now you could recognize that this will come out to a difference of squares, 1 minus sine squared x. If you want to do the whole thing, great, but those middle terms will always go away. Then on the bottom, I have cos squared x times 1 plus sine x. Again, I never multiply through the denominator until I check to see if it can be simplified. Then I see my Pythagorean identity. I'm going to replace 1 minus sine squared x with cos squared x all over cos squared x times 1 plus sine x. And then cos squared x divided by cos squared x is 1 over 1 plus sine x. So I used the conjugate trick to turn left side into right side, and my last giant check mark. All right, so hopefully you're feeling a bit confident about trig identities, and this is the last trick I give you, and then from now on, so this last quick check is related to this one, but then you should do more trig identities, right? Not ones where I've said, okay, this is this trick, right? You're gonna just look at a trig identity and be like, what should I do? What do you notice? You know, should I add? Should I change everything to sines and cosines? Should I factor, right? If you're struggling with these, definitely get some help. They can be fun.